Hello everyone. In this video I'm going to demonstrate and explain one of the methods for giving MPLS Layer 3 VPN customers internet access. Now this isn't commonly deployed anymore, just down to the speed now of MPLS lines being maybe 10 megabits per second, whereas a normal internet connection being potentially hundreds of megabits. So I mean it's good for a backup line, but it's not commonly deployed as a primary means of connecting to the internet. So this is the topology. It's the same one that I've used in previous videos for MPLS Layer 3 VPNs. The only difference is this section up here with the internet router and NAT1, which is just how GNS3 is connecting me out to the internet. So in this video we'll be able to properly demonstrate that these customer sites are able to access the internet properly through this up here. So the way we're going to do it in this video is by implementing NAT on the customer routers and then using route leaking on the PEs, being able to get the customer traffic out of the VRFs and up to the internet router, and then on its way back into the VRF on the PEs, and then down to the customer. So that's what these public blocks are for here. So the customers will be assigned an address in here, because another way of doing this would be to allow the customer source IP, the real source IP, the private IP, all the way up to the internet router, and then on the internet router doing the NAT. But what that means is that the internet router P1, or in the case of customer A site 1 going out to the internet, that would require the internet router P1, P2 and PE1 to know all of the private IP ranges that are in use within customer A site 1, because when that gets translated on the internet router has to know how to get back to the original source. So it needs to know, and likewise with the other sites, these core routers would have to know all of the private IP addresses for the customers, probably using some sort of static routing, because we're not running BGP all the way up here with the customer. So you'd probably have to have static routes on the internet router pointing the subnets down to the PEs so that the internet routes could get back to the real source of the traffic. So we're eliminating that here in this demonstration by doing the NAT translations on the CE routers using one of these public blocks, so that all the routers in the path need to know is how to get back to the public block, which will take it to the PE, and then the PE, being the PE router, will know about its customer connections on it and where they need to go. So what we'll do is we'll start off up here and we'll get the addressing on all of this and get this side configured, and then we'll start on PE1 and PE2. In this, just for brevity's sake in the video, we're just going to say that customer A, site 1 and site 2 are the only people that are wanting internet access, so we'll leave this side just for the shortness of the video. So let's come on to the internet router. So let's get some interfaces configured. So the WAN interface up here, in GNS3, this is going to give me a DHCP address. So let's get that kicked off, and then we'll set that as the outside. Because this is presenting a private address and we've got all sorts of public addresses in here, I'm going to have to do NAT on this router, just because of the addresses we're using and the fact that I can't static route everything back in. So we've been assigned an address. Okay, so let's go on gig 00, or gig 60, sorry, and set the IP address as up here we're looking 80.1.99.1, we'll use a /30 mask, and we'll set that NAT as inside. And it looks like it's saying I've got a duplicate address, so I'll just switch that to 2. Obviously, there's an IP address down here on P1, so I'll just switch that. So now let's just quickly configure an access list for NAT. I'm just looking at the addresses. We should be able to get away with 80. Ooh. And then gig 00, and we want to overload this, so we're using port address translation. So we do want this to be in the OSPF network because it's going to need to know where loopbacks are and stuff like that. So root to OSPF 1, and we'll do a passive interface default just so it's not throwing hellos out of the gig 00 interface. And then for simplicity, we'll do a network 80. And we're using area 0, so that should, a second, bring a neighbour shape up with P1. Cool, right, that's come up now. So what we'll do now is we'll configure a BGP pairing between P1 and the internet router, just so we can get the public blocks that are going to be sent from the PEs up here. So this will be an iBGP pairing, so we'll be within the same autonomous system. So BGP 65991, BGP default IPv4 unicasts using the new syntax. So neighbor 80, what address did I use on here? 2, so it's 1, remote AS 65991. And we're not sending any networks, just want to activate it within there. And then what we'll do is come on to P1, do show run. Believe I'm using the old syntax, yes. Oop. Remote AS 65991, and I don't need to activate that. That should come up immediately. One thing I do want to do actually is on this internet router, go back into BGP and back into the address family, we want this to send a default route to P1. So the P1 has got a default route that points everything out to the internet router. We could configure a static route on P1, but it's just a bit easier to have the internet router present one via BGP. So if we come back onto P1 and do show IP BGP, give that a second, we'll just clear. As I am impatient, that should have kicked it into live. Yes, there we go. So we see our default route here. So if we do a show IP route, we can see that our gateway of last resort is 80.1.99.2, which is the internet router. So what we should see now is that P1 is able to access the internet. So obviously we need to make sure that we choose an address that isn't already within the network. So using 1111, which commonly people would use, would just ping the loopback. So I'll use Google's DNS, and there we go. We can see we do have internet from P1. So what we need to do now is we'll come down to this area down here for customer A site 1, and we'll start doing our configuration here. One thing to note, that on P1's BGP configuration we are already doing default originate. So for example, P1, if I do a show IP route, has already got a gateway of last resort pointing as P1. Again, you could put a static route on the PEs pointing it to quad 1, but we're just using BGP because it's a little bit easier and it's automatic. So on PE1, what we're going to need to do is we're going to need to sort out this public block, and we're going to need to set up a sub-interface between these here, between the customer and us, because if we're doing NAT, we need to separate the internet traffic from the site-to-site traffic, because if we throw NAT on the CE in its current state, what's going to happen is when you're doing site-to-site communication, so a client in site 1 talking to a client in site 2, what that'll do is if we configure NAT on these routers straight away, that will NAT that IP address as it comes through. So if you've got ACLs and stuff down in the other site that's looking at RFC 1918 addresses up at customer A site 1, they're not going to get hit because you're going to be translating it to the address on here. So we want to make sure that site-to-site traffic stays untranslated, so the private addresses can carry all the way across the MPLS network, but then anything that wants to go out to the internet, or anything that isn't in the routing table, should be natted to one of these public block addresses, and it should be thrown out towards the internet. So let's come on to P1 and let's go into gig 00 and we'll choose VLAN 901. I'll do encapsulation.q1 901, and then actually we'll do VRF. We still want this to be on the VRF for the customer, because we don't want them to have access to the whole global routing table of the ISP, because that would be terrible. So let's do that, and then IP address. What we'll do is we'll do what's the address there, 17, so we'll do 62.254.17.1, and we'll do a /30. So if we come on to customer A site 1 and do a do show IP interface brief just to check, yes, we've got addresses. Encapsulation.onq901, and then on here we'll do 62.254.17.2, again with a /30 mask, and then let's just double check that we've got comms with the PE. We have. Cool. So what we need to do is set up, has this already got a default route on it? It does. So that's probably, it's coming from BGP, so what we need to do is on PE1, let's just have a look at the BGP configuration on PE1. Yeah, we can see there we're doing default originate. So what we need to do, because currently everything here is in a VRF, so when traffic comes back in, when it knows where it's going, which we'll do in a second, but when it comes back onto PE1, the global routing table in PE1 needs to know how to get back to the customer, because if we do, actually let's have a look, if we do a show IP route for the VRF customer A, we can see that in here we've got this 62.254.17.0/30. That's in there as a directly connected network. But if we look at the global routing table, we do not see that route in there. So all of the internet traffic up here is going to be using the global routing table. So even if this traffic could get out of the VRF, when the internet router sends it back and it somehow gets back to PE1, PE1 is going to be looking in its global routing table, trying to get to 62.254.17.2, I think it was, on customer site 1, and it's not in the table. So we can tackle that two ways. We could add a static route onto PE1 to point the address down the interface. That's a valid way of doing it. However, it's very manual. So if you had a lot of customers on a PE, you'd have to add a route for every single customer, which, depending on how many customers you've got, it could be a lot, or it could be just a few. But in this case, what we're going to do is we're going to leak the route from the VRF into the global routing table using a prefix list. So the prefix list will match that public block, and if it finds a route in the VRF that matches the prefix list, it's going to pull it from the prefix list. No, sorry, it's going to pull it from the VRF and put it into the global routing table as well, so that when the traffic comes down, from when the return traffic, comes down here and it gets to PE1, PE1 has got an entry in its routing table, so it knows how to get back to the CE here. So to do that, what we need to do is first, because the route leaking uses BGP, we need this 62 address in the BGP table for the VRF before it's going to appear in the global routing table. I'll show you that when it comes across, because you'll see it has a B next to it to show that it is a BGP route. So back to where we were. I'll just refresh that. So we've got it at the bottom of the screen. So we need to set up a... Actually, if we come under... Ooh, I'm already there. If we come under here, and what we want to do is we want to get rid of that. Yeah, and we want to do a network of 62.254.17.0 with a 30 mask, and if we do a show IP, actually show BGP for VRF customer A, we should see, yep, that is there now, and it's being self-originated. Obviously this isn't going to go anywhere because it's already sat in the VRF routing table here as a directly connected route, so this isn't going to change anything in the global routing table. So what we need to do is create an IP prefix list. We'll call this P1 pub block, and we'll do a permit, and what we'll do is we'll do 62.254.0.0/16, and then we'll do a greater than and equal to 30, less than equal to 30. So what that's doing is it's taking that whole /16. So obviously we've only got one customer here, but if you had multiple customers, multiple sites, this prefix list will catch any /30 prefix within this /16. So for example, our /30 prefix is within this /16. So this IP prefix list will pick up that prefix. So now what we need is a route map, and we'll call this leak pub block, and we will match IP address prefix list, and then we'll throw the name there. So now that's all done, we need to come into the VRF definition for the VRF we're working with, which is called cust A, and come into the address family of IPv4, and then we get two options, export or import. Because we're going from the VRF to the global routing table, we are in theory exporting from the VRF. So we'll choose export, and then we'll go map. It's actually no, it's IPv4 unicast map, and then it wants the VRF name, which is not that, is that. Okay, so this will take a second because, like I said, it's it comes to the PE as a BGP update, which seems a bit weird, but trust me. Show IP route. Give it a second just to receive the update and everything like that. So that took a little while in my test environment, but we can see that here we can see that 62.254.17.0/30 is directly connected out of gigabit Ethernet 0/0.901, which is that sub-interface on PE1. And as you can see here, it has come in as a BGP route. So if we do a show IP BGP, we can actually see that in the BGP table, which is, it's a little bit weird, but it gets it from the VRF into the global routing table. So what we need to do now is we need to advertise this, because currently only PE1 knows about this /16 network. We want everyone to know about it, so that if any traffic goes out to the internet from one of PE1's public block, that traffic can get back to PE1. So what we'll do is we'll make use of the aggregate address in BGP as a kind of a way to summarize all of these public blocks, because there's no point, if you've got loads and loads of customers, there's no point just advertising /30s for every single customer if you know that they're all going to fall under one /16 block. So if we do a address family IPv4, and we'll do an aggregate, actually we do need to advertise the network first, and then do the aggregate address of 62.254.0.0 with a /16 mask. There we go. So what we should see is on P1, if we do a show IP BGP, and I have just realised I've forgotten a key command on the end of that. What we want to do is we want to specify summary only, otherwise it kind of defeats the object of us trying to reduce the amount of routes. So what that'll do with the summary only is it will only advertise the /16, where you can see on here it was advertising the /16 and the /30. So we'll give that a second, or as I am impatient, we'll do a clear IP BGP soft out. There we go. So we've just got the /16, and what we can see here is the next hop of quad 5. What we need to do, or we don't need to do it, but you need to make sure that this is done, is if we do a show run section BGP, you need to make sure that next hop self is set, because if we look at this with the /16, what can happen is, because that's come from the VRF and the next hop is the customer, that can sometimes appear in the BGP table with the CE as the next hop, and obviously the internet router and P1 and even PE1's global table can't see that. So we need to make sure that when P1 is sending that update outbound, it's swapping the next hop address to be itself, which is what we can see here. We can see the next hop is quad 5. So if we look on the internet router, we should see something similar. Yep, so we can see the /16 and the next hop being quad 5. So coming back onto the customer router, I removed the static, or the default route coming from P1 via BGP, because what we want to do is, instead of pointing the default route at the 80.1, we want to point it at the 62.254 address. And because we don't have a BGP session with those addresses, it's a little bit difficult to do the default originate and have it get that address rather than the 80.1.17 address. So we'll just do this statically for now. Okay, and the other thing that we need to do actually is, we've allowed the internet traffic back in this way. What we need to do is, on P1, we need to configure a static route out of the VRF, because if we do a show IP route for VRF customer A, we can see that we do not have a gateway of last resort, so that if traffic comes into here and it doesn't fall under one of these addresses, the router isn't going to know what to do with it, and it's going to drop it. So there's a special syntax for this. So we need to do IP route for the VRF customer A, and then we do the standard, and then what we need to do is we need to send it up to P1. So we'll use P1's loopback, and then this is the special bit, we need to type global at the end. And what that means is, it specifies that for this VRF route, the next hop is in the global routing table, because obviously the VRF has got no idea where quad 1 is, but if we specify global, the router knows that that next hop is in the global routing table, and to look it up there instead of within its own table. So if we do that again, we can see the gateway last resort is quad 1. So we now have traffic being routed out of the VRF and up to the internet, and we should have traffic coming back in to the VRF coming from the internet. So we should have bidirectional routing. So we can test that. So on the customer, we should be able to ping 8.8.8.8, and we're going to source that from this address here, and we can see that that is succeeding. And if we try it without the tag, we should see that that won't work, because the routers in the path, at least the internet router P1 and P2, don't know where 80.1.17.2 is and where it resides, but they do know where 62.254.17.2 is. So to make sure that nothing has been affected by that, we can also make sure that that site 1 can ping an address. It still can. It can ping this address that's on site 2, And if we come on to this router and do a debug IP ICMP and do that ping again, we can see, actually I need to source that from loopback 0, apologies. So we're sending it with a source of 10.1.1.1, and we can see that both the source and destination are private addresses, so we haven't lost visibility between public addresses and private addresses. We're still customer to customer, site to site, we're still seeing the private addresses, we're not doing any translation. So let's replicate this down on PE2 so that we can get this secondary site for customer A onto the internet. So on PE2, what we'll do is do show IP interface brief. We'll configure going down, it's gig 00. Just configure the subinterface. And then here we've got a slightly different, only by one, 62.253.19.1 with a /30 mask, and I've just realised that that's going to strip the IP address off. There we go. Great, so let's do it. Let's just familiarise with the BGP configuration so that we can come in here. We want to get rid of that, and we want the network 62.253.19.0 with that of a mask. And then while we're here, we will do the same thing and do the aggregate address. Making sure this time that we do summary only. Cool. So already we should actually see that appear up here in a second. While that's doing that, actually, we'll come onto the customer and just turn debugging off for a second. Use the same tag. .253.19.2. No need for any VRFs on this side. And we'll just double check that we do definitely have comms with the PE. And we do. So let's do a show IP route. We don't have a gateway last resort set, that's good. And we'll point that at the PE. So let's come back onto PE1. Why hasn't that appeared yet? Of course, we need to leak it first. So let's do IP prefix list. This is the same as the one that we did on P1. So what we'll do actually is do a show run. Okay, add the name pub in it. Yeah, there we go. We'll just steal that, and we'll just change that octet there to 253. There we go. And then root dash map leak pub block, and we will match the IP address prefix list. Doesn't really matter about the name there, but let's come into VRF definition for customer A. Go into the address family of IPv4, and again we're exporting IPv4 unicast map, and then we'll throw that name there. And again, yeah, we'll have to give this a little bit of time for it to appear in the routing table. There we go, that has appeared. So we've got 62.253, that's the summary address, but we do have this, which is the subnet we used between here. And we can also see on here actually that we can see the network that PE1 is advertising. We can see that it's advertising its loopback as the next hop. But for PE's sake, we can now see this network. So that should mean that because this is in the global routing table of PE2, it should now be appearing in BGP. Yes, where it wasn't before, because it wasn't in the global routing table of PE2, so BGP wasn't advertising it. So we can see it's on PE1, and we should be able to see that it's on the internet router as well. And we can, perfect. So what we need to do lastly is, if we do a show IP routes VRF cost, if I can spell cost A, we can see again the gateway last resort is not set in this VRF routing table. So what we need to do is the same thing as we did on PE1. We need to do that special syntax static route which points it to P1. So IP routes for the VRF customer A, and we're still going to use P1 because it's the one connected out to the internet, and then we'll specify global. And we should now in here, yes, see that. So to confirm, the VRF in PE2 has got a route out of the VRF up to the internet, and the internet router has got a route pointing back again, next hop self, to PE2 quad 6. So the internet router has got a route back for this public block, and then when it gets all the way down to PE2, if we do a show IP route for the global routing table, there is a BGP leaked route for the specific /30, because if this customer down here wanted internet access as well, there'd be a different /30 for it. So there's a more specific route here which is going to push it down gigabit Ethernet 0/0.901, which is our sub interface. So we should be able to come onto the customer router, sorry, and we should be able to ping quad 8. We're going to source that from the 901 tag, and we can see that is succeeding. So, and again, to prove that nothing has gone untoward, we'll do it on here, debug IP ICMP, and I believe this is on there, so we'll do ping, and I'll make sure this time to source it from loopback 0. we can still ping that. So we've still got customer to customer, site to site contact. And again, we can see we are still using the private addresses. We're not doing any translation on this customer site to customer site traffic. So anything, any policies within these sites that's reliant on end-to-end private addresses is going to be fine with this. But now these two customer sites have got access to the internet through this new area up here. So I hope this has made sense, and thank you for watching.